Hi, in this video we'll compare two physics phenomena called evaporation and boiling. Before you watch this video, make sure you already check out the two videos I include on the playlist. One show you how boiling looks like in case you never see boiling before, and the other one will be evaporation. So try to make observations and then you can understand better. And after you watch this, I would like you to try filling in the blanks on this page on your note. And if you don't know the answer, you can also try to look up your textbook. That should be topics 5.09. So pause the video and try it yourself now.
A few moments later.
So before I check the answers with you, I would like to show you the simulation again so that you can visualize this, because that is the most important. You need to imagine by using particle theory. So back to the simulation that we used earlier, then here I have selected water and I would like to change it to liquid. Okay, so you can see the temperature is at 13 degrees Celsius. Apparently, you should know that boiling only happens at boiling point. So that's something you should have learned in integrated science earlier. And for water, the boiling point should be 100 degrees Celsius at the usual atmospheric pressure. The reason why I said this is because when you are at different pressure, then the boiling point can be changed. But of course, normally when you're living probably at home or like usual altitude, then the pressure will be kind of constant. As you know, it should be 101 kPa, and therefore normally it shall just be 100 degrees Celsius. So back to here, you can see that nothing special, right? And all particles would just be behaving like liquid. And if I try to heat it up, okay, to say 78 degrees Celsius, in fact, you don't need to be that high. You can still do it for maybe 30 degrees Celsius, although the effect of evaporation may not be that significant. So right now, at this kind of random temperature, you can see there's one kind of float, right, away from the main group of molecules. There's one here, there's one here, there's also one here. So those would simply be the water vapor that got evaporated. Remember, the word is evaporated, not boiled. So we have to look into why they would behave like that. Why not just stay in liquid and become gas when we are at 100 degrees Celsius? So here is a screenshot that I take, and I'll try to explain to you further. So if you look at the main group of particles, again, they are at 78 degrees Celsius right now. So they will be having a relatively higher average kinetic energy. In thermophysics, when we talk about temperature, that will be referring to the average kinetic energy. You probably have learned it in year 6 when you talk about the kinetic energy of solid, liquid, and gas. And for sure that you know when you have greater temperature, then the kinetic energy of the particles will be greater. Notice that here we are talking about microscopic. Okay, we are not talking about macroscopic. Macroscopic means what you can see from your eye. So earlier when we are learning about energy, when we study about work done, GPE, and also KE, that KE is talking about macroscopic. So it's literally, for example, my calculator is now moving. Okay, so that is the macroscopic KE. They as a whole move together. However, when we talk about in terms of temperature, it is talking about the microscopic. So like for example, again, this calculator, if I don't move it, they still have KE because the temperature of this calculator is probably the room temperature, and they will still vibrate. If you remember, only particles above the absolute zero temperature, which is negative 273 degrees Celsius, all of them will vibrate as long as you are above absolute zero. So it's vibrating. Can you see that? Of course you cannot, because it's microscopic average kinetic energy. Anyway, so back to here, you may realize that, hey, then so what? They have Ke, of course, but then that doesn't mean they can escape from the attraction force between the particles. So the key idea is average. So think about this. When you talk about average of a group of people, for example, the average height, okay, of our class. So we may find, the average height, for example, is 170 cm. Okay, I'm not sure that is applicable, but then let's say this is the height. But then it does not mean everyone is 170 cm, because this is the class average only. So of course, some people may be 180, some people may be 160, and then eventually, I'm sure you learn in maths, you add them up together, divided by n, then that's how you get the average. And this is the idea of how we get 78 degrees Celsius. However, when you look at the group of molecules, then they will collide with each other randomly. As you know, I mean, they don't have any soul or anything, but that they would be colliding with each other and passing on the kinetic energy and also the momentum. Well, let's not think about momentum. Let's just think about Ke first. So that means not all of them will have the same Ke, and therefore some of them will be having higher Ke and some of them will be having lower Ke. Okay, and so this is why for some of them, eventually there must be one or two or a few of them having enough Ke to escape, to overcome the attraction force between the molecules. And that is the similar idea as in simply imagining for the Earth, if we want to shoot a rocket, okay, sorry, I can't draw it, okay, rocket, you need to have enough fuel to give you enough chemical energy to overcome the attraction force, that is the gravitational potential energy of the Earth, so that you can escape from it and reach to the space or to the moon at least. If not, then what happened? The rocket will simply come back down if you don't have enough energy. So the same idea here, those who can escape must have enough energy to leaving the main group and not coming back again, okay, unless they somehow lose the energy and therefore they maybe come back down. That is how sometimes you find condensation in your daily observation. The other thing that you may notice from your textbook is saying that the evaporation will also give you something called the cooling effect. Okay, and that is saying when you evaporated a certain particle, the remaining group will have a lower temperature. Okay, so once again, these can be explained using the idea of average. Think about this again. If our average height in the class is 170, and for example, someone who are really tall, okay, I'm not going to call the name, but let's say someone who is 190 cm, okay, tall, and then somehow let's say he or she is absent today, alright, is sick, taking a sick leave. And so if I just try to recalculate the average height of the class today, okay, when this guy is not in our class temporarily, then obviously you should know that the average will be lower because we don't count that tall guy, right, 190 cm. And that's the same idea when we look at the main group of molecules here, because this one, the one that being evaporated already, is gone, and therefore leaving you with the remaining one, originally 78 degrees Celsius. However, if you keep doing this, then you have less and less average kinetic energy, and therefore will lower the average temperature of your substance. And so this is called the cooling effect, and that is why it's important when you are doing sports or exercises, you need to drink enough water, because when you drink enough water, then you can produce sweat, And for the sweat, is actually a protective system from your body, where when you sweat it out, and apparently the sweat would hopefully can evaporate, and that's why you want to wear some clothes that help you to evaporate, and that can take away the heat of your body, because when you're doing exercises, then you will produce heat. That is from biology, the idea of respiration, that produce energy, and energy convert to heat. And if you overheat your body, apparently it's not good. So that's why we need cooling effect, right? And that is done by the evaporation of the sweat. Okay, so let's wrap up the idea on the note. So first of all, for evaporation, the kinetic energy of each particle can never be the same. So again, same as the height of our individual in the class can not be the same. You can always calculate an average like 170, but it's almost impossible that is exactly the same. And then the same thing is the collision keep happening, and therefore some of those particles maybe luckily randomly get more energy, and therefore those will be the more energetic particles get escaping. As we said, when they escape, they will have lower average Ke for the remaining liquid, and therefore the temperature decrease. Okay, that's the cooling effect. That's the same as if you wipe alcohol on your body. Nowadays, I'm sure because of COVID-19, you experience a lot of alcohol, right? If you simply rub on your hand and you find, oh, it's kind of pretty, giving you like a cool sensation, and that's the same idea. Here are 4 factors that can increase the rate of evaporation. The first one, that is having more particles have enough energy to escape, so apparently is to increase the temperature itself. I mean, if you think about the average of the temperature, if all of them are nearly boiling like 90 degrees Celsius versus 20 degrees Celsius, of course, the 90 degrees Celsius, that one can be more likely to have particles, although not all of them can escape. You can still find more easily some of them can randomly collide and get enough energy, so increasing temperature can help. Second thing is you would want to increase the surface area. So using that, then think about when the liquid escape, of course it has to escape from the surface. It's like you shoot a rocket from the earth. Of course you shoot from the surface, you don't shoot from the earth core. That doesn't make sense. So spreading out the area, and also you can see from the experiment video earlier, you find out it would increase the rate also. Number 3, I mean, if you read it, you can find out apparently something to do with humid. So apparently it's something to do with the word humidity. Okay, that is how moist in percentage it is in the air, and we want the humidity to be low instead, and that is dry, you may say. And the idea of humidity is simply accounting for how much water vapor is in the air. So for example, when it is raining, usually the humidity is very high because it's just getting so wet and so humid, so moist everywhere in the air. And then during usually winter or autumn, it's getting dry. Even maybe your skin will get dry, and therefore you may want to put on some lotion sometimes to kind of moisturize your skin as well. And so apparently for water, if you want to evaporate water more efficiently, more quickly, then lowering the humidity will be better, because in that case, then the particle can be more likely to go into air without condensing back to liquid. Number 4 is to remove the molecules before they can return to liquid. And so you have to imagine that, oh, what happened is the particle may go up. Okay, this is a beaker, and then if this particle can just be blown away, okay, and apparently there's no way that it can get back to the beaker in this case. So what it actually does is by the wind. So instead of saying increase the wind, let's be more specific. Wind speed. Okay, so increasing wind speed. So That is why you should find out when it is more windy than the clothes. I'm not sure if you do. Probably your parents or your helper will do that when you hang it close. If it is more windy, it's going to dry more quickly. Next is to make the comparison. Evaporation occurs on the surface, okay, because it has to escape. So again, it has to be at the surface of the liquid, while boiling occurs at, usually if you heat it up, you heat up at the bottom, right? So therefore, we should put down bottom. In fact, it could be anywhere, all right, as long as like throughout the beaker, if it is reaching the boiling point, 100 degrees Celsius, then it will be fine. Boiling here is more talking about the rate. So I can understand that if you don't understand, I mean, if you don't get what I'm asking you. So here, boiling occur rapidly. Okay, that's a word you can find. While evaporation occurs slowly. Yeah, you can never see evaporation go rapidly. That doesn't make sense usually. Evaporation constantly occur at any temperature, so not room temperature, not high temperature, but any temperature. All right, it just affects the rate. It's like the possibility or probability of having how many particles, but then actually it can do at any temperature. It's just about more or less. While boiling, again, can only happen at a fixed temperature. So we don't say boiling temperature, we say boiling point. So, and also for water, it will be 100 degrees Celsius. However, for some other liquid, it will be different. So I think it's better to put down fixed temperature here. And lastly, we can see something called bubbling. Okay, as apparently you can see that from the demonstration, or next time when you boil water, probably you use electrical kettle only, but you can probably hear the sound, right? Like blah 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 blah. that's boiling. So that is something you see in boiling, but then in evaporation, you never hear that. You never hear blah 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 in evaporation. That doesn't make sense once again. So for now, I would like you to try a past paper question in IGCSE. So in your note, the next 2 pages will be the question. So pause the video, try it yourself.
A few moments later.
Okay, let's check the answer. For first part, it asks to describe what happened during the process of evaporation. So the very standard stuff. So the first thing that you may want to say is saying due to random collision, some particles or molecules can gain enough Ke, or I should say higher Ke, okay, and which would be enough to overcome the attraction force. So this should be the second point. Number 2 is asking you why the puddle dries out more rapidly than the water. So apparently something to do by observation you can see is the surface area. So the first thing is to state this as a fact first. So you can say the surface area of the puddle is greater than the dish. Okay, that's one thing. Number 2, because of this increases the chance of the energetic, right, which is the one that we say with higher Ke, energetic particles to reach the surface. Okay, and you can also say other than the chance of energetic particles, you can also say more particles, alright, can reach to the surface. Number 3, state 2 changes that would make the rate of evaporation more rapidly. So that's basically the factor that we mentioned earlier. So you can say increase the temperature. Okay, and notice that here it just I just state, so you don't have to explain why. No need to explain why. Earlier, this is explained, and then here is described. So you have to look at the command word carefully. And then here you can also think of increasing the wind speed. Okay, remember the word speed, right? Not just increase wind, because that wind is like a noun, right? You can increase certain thing, but you can increase the speed, because wind is not countable, right? So you can't say increase in quantity. You could also say lower or decrease the humidity. Part B is very interesting. Before the time of having refrigerator, this is one of the way to keep something cool. And imagine the emperor in the past may ask people to just do this, so then he or she could enjoy the cool drinks still, alright, using this more traditional method and clever method. So here is asking you why this can keep the milk cool. So first of all, you should notice that this is the damp cloth, and so that means it's soaked in water. So what you can say is the water will of course evaporate from the cloth when the more energetic, so again you have to use the words that we have learned, more energetic particles escape. Alright, and then that's probably one. And then number 2, which is very important, leaving the remaining liquid with lower average kinetic energy. Okay, this is probably the hardest sentence and the one that requires the most technical words. So you need to make sure you have the word leaving lower average kinetic energy, alright? And well, I mean it's literally the whole sentence anyway, so you can't miss any word basically or change much from the wording. And then number 2 was just saying the water get cooler, right? Or you can say, you can just simply add that is the cooling effect. I'm not sure if these count as 1 mark, but let's say it is. Then you want to write more, right? Although I know it's only 3 marks. You would want to say then the thermal energy, because water is cooler, then thermal energy would transfer from the milk, because the milk is of a higher temperature, to the water, alright, on the clothes basically. So therefore the milk would get cooler.